Hi everyone. Today we're diving into the world of virtualization by answering those key questions. What are hypervisor? How are they classified? What are their characteristics and how does their architecture work? Let's get started. In the first question, what are hypervisors? A hypervisor, also known as virtual machine monitor, is a software of hardware layer that enables the creation and management of virtual machines. Think of is a bridge between physical hardware and virtual environments, allowing multiple operating systems to run on a single physical machine. The second question is how are they classified? Hypervisors are typical in two types. The first type, or bare metal hypervisory, run directly with the hardware without the need for underlying operating systems. And the second type, or hosted hypervisors, operating of the top and existing operating system. The third question is what are their characteristics? Hypervisors have some different characteristics, such as a research installation. Each virtual machine operates independently, ensuring stability and security. Scalability, they allow you optimizing hardware used by running multiple virtual machines, and resources allocations, they manage CPU, memory, and storage dynamically across virtual environments. And the last question, explain their architecture. Hypervisors use a linear architecture. In type 1, the hypervisors interact directly with the hardware, managing resources and creating some virtual machines. And in the type 2, the second hosted hypervisor work through the operating system, which in turn communicate with the hardware. Both types include the control layer of the manage the virtual machines and guest layer where the VS run.
What is cloud computing? Cloud computing refers to delivering computing services like servers, storage, databases, networking, software, and more over the internet or the cloud workspace. It eliminates the need for owning physical hardware, offering scalability, flexibility, and cost efficiency. You simply pay for what you use. There's nothing else. Now, are hypervisors used in cloud computing? Yes, of course. Hypervisors are a crucial component in a cloud computing. They enable virtualization by allowing multiple virtual machines or VMAs to run on a single physical server. Cloud service providers like AWS, Azure, and Google Cloud rely on hypervisors to maximize resources utilization and isolate workloads securely. Without hypervisors, the modern cloud wouldn't exist as we know it. Now, let's talk about costs. A physical server requires a large upfront investment, hardware, space, maintenance, and power. In contrast, a cloud-based server operates in a pay-as-you-go model. While the cloud may seem more expensive in the long term for high-demand environments, it saves money by eliminating the need of hardware maintenance, upgrades, and over-provisioning. Now, what are containers? Containers are lightweight, portable units that package an application and its dependencies together. Unlike virtual machines, containers share the host operating system's kernel, making them much more efficient. They are built on container engines like Docker and are orchestrated using tools like Kubernetes. This architecture allows developers to deploy consistent environments across various platforms. And for last, but not less important, similarities and differences between virtual machines and containers. So let's compare virtual machines and containers. Both allow you to run multiple applications on a single server. But here's the difference. Virtual machines emulate an entire operating system, including its kernel. They're heavier and consume more resources. In fact, containers, on the other hand, share the host OS kernel. They're lightweighted and start up in seconds. Now, the similarities are that they both improve resource utilizations and they both are great for isolation and security. And the difference are that VMIs are better for running multiple operating systems. On the other hand, containers excel at running microservices and cloud native applications.